Hello everyone. Welcome to the very first episode of our educational series on the Cranmer Abacus. I'm Ryan Aparicio, a special education teacher for the blind and visually impaired here in the Philippines. In this video series, we will explore a tactile math tool that has empowered thousands of blind students to perform math independently and confidently. Whether you are a learner, a parent, a teacher, or someone simply interested in accessible education, this series is made for you. What is the Cranmer Abacus? The Cranmer Abacus is a tactile mathematical device designed specifically for blind and visually impaired individuals. It is modeled after the Japanese abacus, also known as the soroban, but with modifications that make it more accessible for tactile use. It allows users to set and manipulate numbers using their sense of touch, making it a practical tool for solving mathematical problems without needing to rely on sight or electronic devices. The Cranmer Abacus was invented in the 1960s by Tim Cranmer, a blind inventor, mathematician, and advocate for the blind community. His mission was to create a tool that would enable blind learners to work on math problems independently, without the need for sighted assistance. Since its introduction, the Cranmer Abacus has been widely adopted by schools for the blind, rehabilitation centers, and homes worldwide. It continues to be a powerful tool for developing math skills and building learner confidence. Now let's take a closer look at the physical features and key parts of the Cranmer Abacus. A typical Cranmer Abacus measures 3 1/4 inches by 7/16 of an inch. It's compact in size, designed for portability and ease of use by blind and visually impaired users. The abacus has 15 vertical rods, and each rod functions like a column where numbers are represented. On each rod, you will find 5 movable beads, 1 bead above the separation bar, and 4 beads below. This separation bar is a horizontal divider that runs across the frame. It plays a crucial role in distinguishing values. Beads above the bar usually represent a value of 5, while those below represent 1 each. Similar to how place value works in base 10, let me briefly highlight the major parts of the Cranmer Abacus. Vertical rods. These hold the beads and represent columns or place values. Movable beads. These are the counters that are slid up or down to perform calculations. Separation bar. This is the horizontal line that helps differentiate the place value of the beads. Understanding these components is essential before we can begin learning how to use the abacus for arithmetic operations. Let's now talk about the key features that make the Cranmer Abacus especially useful for blind and visually impaired users. First, it has raised markings. These tactile indicators help users identify reference points on the abacus, such as every third or fifth rod, making it easier to keep track of place value by touch. Second, the abacus is designed with a soft rubber backing. This feature allows the beads to stay in place once moved, preventing accidental shifts during use. This is particularly helpful for blind users who rely on finger movements and need the beads to remain steady as they calculate. Finally, the Cranmer Abacus is portable and compact. Its small size makes it easy to carry in a bag or pocket, which supports independent learning and mobile use, whether at school, at work, or at home. These thoughtful design features make the Cranmer Abacus a reliable and accessible tool for tactile math computation. Why should we teach and use the Cranmer Abacus in the first place? There are many compelling reasons. First, it promotes independence in learning mathematics. Students can perform basic to complex calculations without having to depend on others or on electronic devices. Second, it strengthens tactile discrimination and fine motor skills. Third, it serves as an alternative or complementary tool to screen readers, especially during power interruptions or in low-resource settings. And most importantly, it supports inclusive and equitable education for learners with visual impairments. Now let's explore the benefits of using the Cranmer Abacus, especially for learners who are blind or visually impaired. First, the abacus improves mathematical skills. Regular use enhances mental arithmetic, strengthens problem-solving abilities, and sharpens concentration. Since the user is actively involved in manipulating beads and visualizing numbers mentally, it builds a deeper understanding of math concepts. Second, the Cranmer Abacus boosts confidence. Successfully performing calculations can give visually impaired individuals a strong sense of accomplishment and independence. It empowers learners to take control of their learning process without depending entirely on digital tools. Lastly, the abacus serves as a reliable alternative to calculators. In situations where digital devices may not be available or allowed, such as during exams or in low-resource environments, the Cranmer Abacus provides an accessible, efficient, and tactile method for performing calculations. These benefits demonstrate that the Cranmer Abacus is more than just a tool, it's a gateway to mathematical empowerment and lifelong learning. Who can use the Cranmer Abacus? The Cranmer Abacus is suitable for a wide range of users. These include blind and low-vision students in primary, secondary, and even higher education. It's also helpful for adults who have recently lost their sight and are learning new skills for independence. Teachers, tutors, parents, and caregivers can also benefit from learning how to use this tool so they can better support learners. Whether you're learning math for the first time or relearning it after vision loss, the Cranmer Abacus can be a valuable part of your journey. In this video, we've only scratched the surface of what the Cranmer Abacus can do. In our next episodes, we'll walk you through the following topics step by step. Video 2, Understanding place value and value of numbers on the Cranmer Abacus. Video 3, Important skills in learning to use the Cranmer Abacus. Video 4, Concepts of setting and clearing. Video 5, Complement of a number and dots on the separation bar, and more videos in this series. If you found this video helpful and inspiring, please consider subscribing to this channel. Don't forget to like, comment, and share this video with others who might benefit from it. Let's work together to make math and education truly inclusive for all. See you in the next video. God bless us.